in this problem, we're told that a patient is being given a blood test for a disease, and the prior probability of having that disease is P. Then the patient's blood test is being sent to two different labs. So we have lab A and lab B. And the choice of which lab the test gets sent to is random. So the probability that the test gets sent to lab A is 1/2, which is the same as the probability that the test gets sent to lab B. Now, for lab A, the probability that someone testing positive, for lab A, the probability of someone testing positive given that they have the disease is A sub 1. So the probability that someone tests positive given that they have the disease and their test has been sent to lab A, this is A sub 1. And the probability of someone testing negative, the probability of a negative test, given that they do not have the disease and their test was sent to lab A, is A2. And we have corresponding numbers for lab B. So the probability of testing positive given the patient has the disease and the tests were sent to lab B, this is B sub 1. And the probability that the patient does not test positive, given that they don't have the disease, and their tests were sent to lab B, this is B sub 2. So we would like, in part A of the problem, to find the probability that the patient has the disease, given that they've tested positive. So we'd like the probability of a patient having the disease, given that they've tested positive. So we're going to use the Bayes rule and law of total probability to solve this. So we have the prior probability of the patient having the disease times the likelihood of testing positive given that they have the disease over the probability of testing positive. So this is the definition of Bayes rule, and we're going to rewrite this as, now in the numerator, the prior probability of having the disease was P. And now we're going to use law of total probability to rewrite the probability of testing positive given that the patient has the disease as the probability that their test gets sent to lab A given that they have the disease times the probability they test positive given that their tests were sent to lab A and they have the disease, plus the probability that their tests get sent to lab B given that they have the disease, times the probability that they test positive given their tests were sent to lab B and they have the disease. Like so. And now we're going to apply law of total probability in the denominator as well. And we're going to rewrite probability of testing positive as the probability of the results being sent to lab A times the probability of testing positive given that information, plus the probability of the results being sent to lab B times the probability of testing positive given that information. Now, in the numerator, we have little p multiplied by, well, what is the probability that the patient's tests get sent to lab A? Well, that we said was 1/2. Independent of whether the patient has the disease or not, the probability that their tests get sent to lab A was 1/2. And what is the probability that the patient tests positive given that they have the disease and their tests were sent to lab A? And so that value was A sub 1. Plus, now the probability of the results being sent to lab B is again 1/2, and the probability of the probability of a positive test coming back from lab B given that the patient has the disease is B1 over. Now, what we're going to do here in the denominator is we're going to say, well, probability that the test gets sent to lab A and lab B are 1/2. So we're going to replace probability of A with 1/2. Now, the probability of testing positive given the test was sent to lab A, this can happen in two ways. So either the patient had, so we're essentially applying the law of total probability again, implicitly. So either the patient already had the disease, and given that they had the disease, the lab gave positive results, so that's this value here. Given that they had the disease, the lab gave us a positive test result, so that's A sub 1. Or the patient didn't have the disease, and the lab gave us a positive test result. So if the patient doesn't have the disease, the probability of a negative test result from lab A is A sub 2. And so the probability of a positive test result is 1 minus that. So 1 minus A sub 2 plus probability of the prior probability of sending the test to lab B is 1/2. Now times the probability of testing positive given that the results were sent to lab B. Well, again, we're going to implicitly apply the law of total probability. Again, we're going to say that can happen in two ways. Either the patient had the disease and the lab reported a positive result, so the probability of that happening is B sub 1, or the patient didn't have the disease, and the probability of lab B reporting a positive test result in that case is 1 minus B2. 1 minus B2. And we are done. So now moving on to part B. Part B says, what is the probability that lab A had done the test given that the test came positive? So we do some test, the test comes back positive, and what's the probability that lab A had done that test? So again, we apply Bayes' rule and law of total probability, so we get the prior probability that the tests were sent to lab A times the probability that a positive test result comes back given that the test was sent to lab A over the probability of testing positive, and this equals, now the prior probability of sending the results to lab A for testing was 1/2, and times, now again we implicitly apply the law of total probability. What are the scenarios under which a positive test result comes back from lab A? Well, it's either the patient has the disease and lab A gives us a positive result, or the patient doesn't have the disease and lab A again gives us positive results, so that would be 1 minus A2. 1 minus A2. Now in the denominator, we're again going to apply the law of total probability, and we're going to rewrite the probability of testing positive as the probability that the results were sent to lab A for testing, and then the test came back positive, plus the probability that the results were sent to lab B for testing, and the tests came back positive. And this equals, so in the numerator we have 1 over 2 times P times A sub 1 plus 1 minus P 1 minus A sub 2. And in the denominator, we have 1/2 for probability of A. Now, testing positive, given that the results were sent to A, it's exactly this expression as in the numerator. So P A sub 1 plus 1 minus P times 1 minus A sub 2. And then the probability of B is again 1/2, and testing positive, given that the results were sent to lab B, are P times B sub 1 plus 1 minus P times 1 minus B2. Just as in part A. And we're done.